All right, for fluids, we're going to go ahead and start with a couple things that hopefully are familiar. The first thing is density. So density, if you remember from chemistry, is mass divided by volume. And so if you have something that is less dense, that's going to be what floats. And the thing that sinks is going to be more dense. Now, oftentimes you think of less dense as floating, as the objects that are lighter. But if it's the same volume, the thing that's lighter will float. And if it's the same volume, the thing that's heavier will sink. The letter for density is the Greek letter rho. And then, so here we have the equation, density is mass over volume. And just be careful that that V is a capital V, because lowercase v is velocity. And then be careful, lowercase p is momentum and uppercase P is power. So we really have to be careful that this rho actually looks like the Greek letter. Now, if you have an object that's floating, in water, the thing that we need you to remember or memorize or write down in a very accessible place is the density of water. And these are weird density symbols, but it's fine. So the density of water is 1,000 kilograms per meter cubed, or 1 gram per centimeter cubed. So the first example we're going to look at is Europa, has a density of 3.01 grams per centimeter cubed, and Europa has a mass of 4.8 times 10 to the 22 kilograms. So first we're going to find the density in kilograms per meter cubed, so just working on that conversion, and then what is the radius of Europa. If you want to pause the video, do the calculations, and then check back in, that's great. Otherwise, I will proceed. So the first thing we need to do is convert this. And so I'm going to notice first that I need to get my grams into kilograms. And I need to remember how many grams are in a kilogram. Well, there's 1,000 grams in 1 kilogram. And because grams are on the top, I'm going to need to put grams on the bottom and kilograms on top. So that way, when I cancel these out, I'm going to have grams on the top and grams on the bottom. That way, the grams will cancel out. And there's 1 kilogram is equal to 1,000 grams. And then I need to do the same thing for centimeters, but it's centimeters cubed. Well, I'm going to remember that 100 centimeters is equal to 1 meter, just like 100 cents is equal to $1. And the reason why it's dollars and cents is this C is cent, and that's centimeter or cents, and that's why there's 100 cents in a dollar. So if you're having trouble remembering how to go from centimeters to meters, just think dollars and cents. Now, if you notice, the centimeters are on the bottom here, so we're going to want the centimeters on the top. And we remember that there's 100 centimeters in 1 meter. But you'll notice that we have this centimeters is cubed. So what we're going to need to do is we're going to need to cube our centimeters because we need our meters cubed. And then we also are going to have to cube our conversion. So as long as you cube the conversion, you can cube the units. So our centimeters cubed will cancel out that centimeters cubed. Our grams have canceled out, and we'll get an answer of 3,010 kilograms per meter cubed. Then once we do that, then we can do part B. So for part B, we need to get that density and find a radius. But in order to find radius, we need to find the volume. So we're going to use the relationship that density is equal to mass over volume. We just found our density up here in part A, so that's going to be what we use for density. The mass was given in the problem, that's 4.8 times 10 to the 22 kilograms. And then we just need to solve for volume. And then once we have volume, we can remember that volume is equal to 4/3 pi r cubed. So I'm going to start by just solving for volume. So what I'm going to do is multiply volume to the other side. And then I'm going to divide by the 3010. So I get a volume of 1.59 times 10 to the 19 meters cubed. And once I have this, now I can go ahead and solve for my radius, because I know that my volume is 4/3 pi r cubed. All right, so I went ahead and multiplied by 3/4 to get the 4/3 to cancel out, and then I divided both sides by pi, threw all that into a calculator, and I get what r cubed is. Now, remember, the opposite of cubed is cube root, and there's two different ways to do that. I can either type it into the calculator as a cube root like this, and I could just find the cube root of both sides, or I can put it to the 1/3. So just like when the opposite of multiplication is division, the opposite of putting something to the third is putting something to the 1/3. And then you just have to make sure you use parentheses. I find personally it's easier to do this and just put it to the 1/3 to find the cube root. Now, if you want to use the special function on a calculator, great. Just I know that this is a reliable way for me to do it. Just you have to put that 1/3 in parentheses, otherwise you will not get the right answer. And then for the answer for the radius, we get 1,561,452. But if we want to be, I could also write it as 1.56 times 10 to the 6 meters is the radius of Europa.